Conjecture is going to be an answer or a conjecture for what's true about this, okay? Now, remember in geometry, it's not just, is this answer true, but is this the only truth forever? Okay, so if you can be that little kid who's trying to prove your parents wrong and find that little loophole, okay, that's what we want to focus on problems like this. If they give you a conjecture, that conjecture has to be true forever and always. Okay, so let's solve this problem that's the given, okay, and divide by 3. A squared equals 16. Now, when you take the square root of 16, yes, it is true that a equals 4, but there's another answer that also works, and if you're not careful, you'll miss it. There is another answer, -4. When you plug in -4 into this equation, it will also work because -4, when you square it, will give you a positive 16. So, if you were to try it, -4 squared is 16, and then 3 times 16 gives you 48. So when you find something else that works, that says this thing that they're saying, this conjecture, is not true forever and always, because this thing also works. So if you can find one counter example, then the whole statement is false. So your answer for number 6 on page 121 is false, and the counter example is -4. Okay, on your test there will be one like that. Read your answers carefully. Don't just choose true just because it works. If you can find something else that works, then it throws the whole thing off. Okay, let's talk about the one that you have to do your converse, inverse, contrapositive stuff with. Number 10 on that same page, 121, says an apple a day keeps the doctor away. Okay, some of your questions on your test today, you will have to put in an if-then form. Okay, so can we write that in if-then form? If you eat an apple a day, check your homework page, then you keep the doctor away. Okay, so that's your original statement. Now, we do need to apply these little words that we learned in Chapter 2, converse, inverse, contrapositive. Where is always your starting point? Remember, this thing is called the conditional statement. That's your if-then statements, that's your starting point, and the symbols that go with that are P and Q. Okay, so just a little reminder here. You guys were doing really good on this when we were back in Chapter 2, but it's been a long time. Where is your P at? Your P is the part that's with the if in your original statement. Okay? And then your Q is called the hypothesis. Your hypothesis is, the Q is the stuff that's with the then part in your sentence. Okay? So these other words that we're going to focus on that we need to know on your test today, you're going to see these. It's going to ask you for the converse of this statement, for the inverse of this statement, for the contrapositive. One of those you're going to be asked for. Okay, so we need to remember those little symbols that go with each one of these. Okay, so my trick, if you want to use it, if you learned it, if you don't remember it, here it is. Okay, converse, if it starts with a C here, remember that's going to be like my English teacher putting little arrows on that little thing that says flip it around. You got something backwards when you flip it around. So that C is just going to kind of clue me, oh, I'll put some arrows on there. That's going to help me remember what do you do from the starting point, from the conditional. We're going to flip around my P and my Q. Okay, inverse, I just do this for myself. I just make that I kind of a fancy I just to help me remember that we got to put the squigglies in there. Now, inverse does not have a C in it, so you are not going to switch it around from the starting point. You're going to leave it in the same order. The only thing you're going to do for inverse is put your knots in there, put your squigglies. So squiggly P, arrow, squiggly Q. If not P, then not Q. Okay? And look at the next one, contrapositive. It starts with a C. So I am going to switch around from the starting point, and also it's got some I's in there. So I'm just going to kind of let this C and I thing help me out here. It's got C's, it's got I's in it. So we are going to do both of them for contrapositive. From the starting point, you are going to flip it around and put your knots in. So if not Q, then not P. Now, we do need to apply these to the sentences. Today on your test, they're not going to ask you for the symbols. But know the symbols, and that's going to help you. It's going to ask you, tell me the contrapositive of this original statement. If you want contrapositive, flip around the order, put knots in. So, if this is your original, if you eat an apple a day, I left that out, then you'll keep the doctor away. So the contrapositive of that statement, if you do not, there's your squiggly, keep the doctor away, here's your Q. Check your paper. Then you do not, there's your squiggly, eat an apple a day. There's your P. Okay. Can you do inverse? Can you do converse? If you need to talk about it after this video stops, then ask your teammates questions, ask Miss Matthews questions, and you guys can do really well on that on your test. Okay. One more thing I want to look at, and that is from that second page on your homework, page 171. Two more things I want to look at. One more thing I want to remind you of. What do you guys know about perpendicular lines and their slopes? Okay, if you're looking at page 171, go to that homework page. That first question asks you to write an equation that is perpendicular to this equation they give you. Okay, this is what you see on there. And they want a perpendicular line to this equation. Okay? Now, the only little trick you need to remember about perpendicular is something about the slopes. Because we can change the slope to be our perpendicular slope, and that's going to graph a perpendicular line for us. Okay? What are the two things you got to remember when you want to do the perpendicular line? You're going to take the slope. One thing you're going to do is change the sign. If it's positive, it becomes negative. If it's negative, it becomes positive. Second thing is you are going to flip the fraction. Okay, so let's apply these for perpendicular slope. Here's your two steps. All right, so what is your slope in this original equation they gave you? Your slope is a coefficient with x. Your coefficient with x is 3. So what is that as a fraction? 3 over 1. This is our original slope. Okay, so if we wanted to write an equation that has that's perpendicular to that, what are we going to do? Change the sign, flip the fraction. So it's positive, it becomes negative. 3 over 1 becomes 1 over 3. This is your new slope, the coefficient with x. Now, does it matter where it crosses the y-axis? Remember, this is your y-intercept. This is your b. It does not matter where it crosses the y-intercept. It could be slid up or down on the y-axis, and it still would be perpendicular based on this slope right here. It does not matter what you want to put in here for your y-intercept. This number could be anything, or you could not even have a number on there, and it would cross through the origin. Okay? So the main thing for your answer for number 1, look at your paper. You got to have that slope with these two steps. Okay. All right, and then on those questions, number 16 through 19, excellent questions there. Let's take a look at those. We could answer number 10, excuse me, not number 10, number 18 together. 18 gives you a picture that looks like this. And you've got 3x minus 60. And you've got 2x plus 15. Okay? And you got y right here. Now, we do need to remember those vocabulary words. Alternate interior, alternate exterior, consecutive interior, and corresponding. Do you know those? Do you know where they're located? Now you take a look at this picture, and my trick is take your x's with x's. Look at the location of those angles. Are those angles any special angles? They are not. Okay, not special ones right there. So we've got to see if we can come up with another game plan. What do we know is true about this location and that location? It's not a special angle for us, but what do you know? Let's look in here at some angles we know are congruent. Now, we hadn't talked about this a whole lot in this chapter, but what do you know about these angles right there? These are vertical angles. What do you always know about the measure of vertical angles? They're always the same. They're always congruent. So if this angle up here is 3x minus 60, can't I just do this? 3x minus 60, just put it right there. Because what does it mean to be the same angle? It means their measures are the same. So if this one's 3x minus 60, this one that's congruent to it has to be 3x minus 60. Because that's what equals mean. It's the same thing. Okay, so I can transfer it right here. I have another x down here. Watch this. If you took this top half and you slid it down onto this bottom half, where would this angle right here end up? Do you see it would end up right here on this other red circle? Those are what kind of angles? These are corresponding angles. Got to know this for your test. But more importantly, you need to know what is true about corresponding angles. If these are parallel lines, corresponding angles are always going to be congruent to each other. So, if they're congruent to each other, I can just rewrite 3x minus 60 right there on top of that angle that it's congruent to, because that's what it means to be congruent. It means they're the same, they're equal. So just whatever's there, write it right here, because we can do that because it's equal. Now, what do you notice right here? 3x minus 60, 2x plus 15. Look at this. They form a straight line together. They are a linear pair. What do you know about the measure of a straight line? You know that the sum, the total, is 180. So when you put these two angles together, the top part right here, the bottom part right here, that's going to give you 180 degrees because it's falling in a straight line. So how do we put two angle measures together? You're going to add them. So your top one, 3x minus 60, plus add 2x plus 15. Here is your setup for x. Add the two angles together, it makes a straight line, so it's got it, the total's got to equal 180. Okay? Now, this is your setup. Let's solve it for x. I'm going to do a little shortcut here. X is 45. Okay, so we should be good with solving it for x. After you get 45, if I want to answer number 18, it is asking me for the measure of FCE, which, by the way, is this angle right here, 2x plus 15. So you got to find your variable first. Okay, when you find your variable, we need to plug in whatever you get for x. Plug it in for x. 45 goes in for 2x plus 15. And now let's solve it. This gives you 90. And then add them together. This gives you 105. Your answer for number 18 is 105. Now watch this. Let me take it one step further. That's this angle measure. We just found it. If that's 105, what can we say about this angle right here where y is? Do you see corresponding angles again? So what does y have